Here we are going to determine the characteristic equation of a 2 by 2 matrix. The characteristic equation is actually the first step in solving for a specific eigenvalue of this 2 by 2 matrix, which will also be helpful for us to solve for its corresponding eigenvector and ultimately the eigenspace. This characteristic equation will help us isolate a certain lambda, which is again the eigenvalue. To do this, we are going to show this process here. Okay, so we are going to come up with the first matrix, a matrix which is the product of your lambda as a variable times a identity matrix minus your A. Okay, your A matrix. And then after you come up with a matrix we represented by this, you take then the determinant of the matrix form to solve for the characteristic polynomial. And that characteristic polynomial, when equated to 0, that becomes your characteristic equation. That is again helpful for us to solve for the eigenvalue, its corresponding eigenvector, and ultimately the eigenspace. So this is how it's done. Take note that our matrices here, both matrix, supposedly it should be matrix B here, but just for the purpose, let's just have A because our formula uses A. We are going to use here an identity matrix, which is also a 2 by 2 matrix. So our identity here that is to be used for both is this matrix here. Okay, so let's start with the first matrix containing the entry 6, -3, -2, and 1. So this is how we're going to do it, just like this. So this is a certain lambda, which is scalar, times your identity 1, 0, 0, 1, minus your A. You will have 6, -3, -2, and 1. Okay? So let's just simply do it this step by step. Of course, you could automatically do it on your own, but just for the purpose for this, of course, multiply this lambda here. So you have lambda, you have this one here, 0, because lambda times 0 is 0, 0, another lambda here, minus, we have your matrix A. Of course, both of our matrices are 2 by 2 matrices, so the difference is defined, and you will have this next expression. You have lambda minus 6, that's your first entry. 0 minus -3, so you have positive 3. 0 minus -2, positive 2. Lambda minus 1, that's your last entry here. So after this is now your the result of this expression. Let's try to solve for the determinant of that. Okay, the determinant of this is, of course, we know for a 2 by 2 matrix it's A D minus B C. So we'll have it here, A, this is your A, lambda minus 6 times lambda minus 1, that's your D, minus your B is a 3 times 2. So you will have here, of course, you can multiply this now because our goal is characteristic equation where we are going to pass a characteristic polynomial. You have the square of lambda minus 6 lambda, then you have minus lambda or 1 lambda plus 6, then this is minus 6. In short, this will become 0. So your characteristic polynomial is lambda square minus 7 lambda. This is your characteristic polynomial. Equating this to 0, this is your characteristic equation for the first matrix. Again, the purpose for this is later on we're going to solve for lambda, which represents the eigenvalue, and then ultimately again eigenvector and eigenspace. But for this video, characteristic equation only. So let's duplicate the process here for the second, this expression here as well. So you will have your lambda times your identity 1 0 0 1 minus your a, which is 1 minus 4 negative 2 and 8. Okay, you close it out like that. So again, this is lambda by matrix. You have 0 0 and lambda. That's lambda, not x. Lambda minus this is still 1 minus 4 minus 2 and positive 8. Combining them, of course, we still have a lot of space at the bottom. So you have lambda minus 1. So you have lambda minus 1, right? Then 0 minus negative 4, so positive 4. 0 minus negative 2 is positive 2. Then lambda minus 8. This is now your expression. Next, a bit further here, we will solve for the determinant of your this expression. You have lambda I, which is your identity, minus a. Again, this is AD minus BC for a 2 by 2 square matrix. So your A is lambda minus 1 times lambda minus 8 minus your B is 4 times 2. So this is, of course, multiply that now, lambda squared minus lambda minus 8 lambda plus 8, and here minus 8, again this is 0. So your characteristic polynomial is lambda squared minus 9 lambda. And equating this to 0, lambda squared minus 9 lambda equal to 0. This is your characteristic equation. This is the goal for this video. Again, don't worry about that. We'll have a separate video as we use this to moving forward in determining the eigenvalues and the corresponding eigenvectors, and together with the eigenspaces. But for this video, we used this expression here. Again, your identity depends on the type of square matrix. This is a 2 by 2 matrix, so therefore your identity is also a 2 by 2 matrix. And of course, use the correct process and operation. Then, concept of determinant. We are going to use determinant to come up with our characteristic polynomial. And equating our characteristic polynomial to 0, you will have your characteristic equation. Thank you very much for watching.